The three purposes for our inclined plane video today is to figure out what DE represents in inclined planes, to figure out what DR represents in inclined planes, and to know what FR is for objects that are going up or down inclined planes. This is going to be a very short video. Inclined planes are nice and easy. Just make sure that you're still using your equations from your packet.
So an inclined plane is really, really basic. It's just a flat surface that's set at an angle. It doesn't have any moving parts, but it allows us to push or pull or drag objects up or down the ramp. So we can think about roller coasters going up that really large hill. That's a good inclined plane. If you're trying to get a lawnmower into the back of a truck, those are all really good examples of what inclined planes are. And they're actually really, really simple as far as the machines that we've talked about. So let's dig into the IMA of inclined planes. So when we think about the equation for IMA, your dE over dr, what that represents within our inclined plane is our effort distance, is how far you have to push that object up the incline. And it turns out to be the actual length or kind of the hypotenuse of the incline itself. So anytime we're dealing with inclined planes, DE and FE are the things that we are physically trying to push. So DE is the length of the incline that we need to push it, and sometimes we just write L to represent that slope or that length. Now our dr is where we're trying to get that object to go. And the dr is essentially the height of your inclined plane, because our ultimate goal is to get it from the ground to that spot. That's what our resistance distance is. And in the equation for the inclined plane, sometimes we write that as h, or height. So what it all boils down to is the IMA for an inclined plane is going to be the length of the slope, or the hypotenuse of that right triangle, divided by the height of the inclined plane itself, or essentially what we're trying to get that object up to. Now when going to IMA, when we have our resistance force over our effort force, what those represent within the inclined plane itself is your resistance force is whatever object you're trying to push up that inclined plane, whether it's a wagon or a box or that roller coaster car. It's the thing that you're trying to push, and that is the weight of the actual object. Our FE, or our effort force, is how much force we have to put in to move that object up our incline. So that's pretty straightforward compared to all the other simple machines that we've dealt with. So again, kind of the only special things to keep in mind for the IMA of an inclined plane is the effort distance is the slope of the incline, the thing that you are pushing up. The height is the resistance distance, and the object that we're pushing up is our resistance force. So we can still use the IMA and the AMA equations. We can just tweak them, modify them just a little bit to represent our inclined plane work.